Hello and welcome to Maths with Jacob. This lesson will focus on Chance and Probability, Part 3. Unequal chances. There are many examples in real life where the probability of an event occurring is equal to the non-occurrence of the event. That is, success or failure have an equal chance of occurring. For example, tossing a head with a coin has the same chance of occurring as tossing a tail. Throwing an even number with a die has the same chance of throwing an odd number. Consider the following picture. Here we have a box with 10 marbles, 3 red, 2 blacks and 5 blues. It is easy to see that the probability of picking a red at random is 3 over 10. The probability of picking a black is 2 over 10, and the probability of picking a blue is 5 over 10. We can easily see that the probability of picking a blue marble is greater than any of the other two probabilities. Hence, this situation is heavily biased in favour of the blue colour, because there are more blue marbles than any other colour. The diagram below is an interesting one to show how probabilities are not equal. Now this is a circle which has been divided into 4 different sectors. The red sector, that's 90 degrees, so that's a right angle there in that red sector. The green sector is also 90 degrees. The pink sector is 45 degrees, that's a small angle. And the blue sector is 135 degrees. When we spin the wheel, we have the following. The arrow has the greatest chance of landing on the blue, because that's the largest area. The red and green sectors are next, because they're the next two largest. In fact, they're equal in size. Finally, the pink sector has the smallest quantity, so that's quite small there, that pink. More specifically, the probability that the arrow will land on a blue is 135 over 360, which is 3 over 8 when you simplify it. The probability of landing on a red is 90 over 360, which is 2 over 8, which is 1 over 4. The probability of landing on a green is 90 over 360, which is 2 over 8, which is 1 over 4. And finally, the probability of landing on a pink is 45 over 360, which is 1 over 8. So you can see that this spinning wheel is heavily favoured towards the blue as the individual colour, which will come up more often. When you throw 2 dice, you will notice that 2 numbers appear at the top. If we consider all the possibilities, we have the following. So one dice has the number 1 to 6 and the other one has 1 to 6. When you throw the 2 of them, you've got these 36 possibilities that will show up. For example, here, look, you've got a 2 and a 5, so that's just one of the possibilities. But there are 36 possibilities altogether. So the yellow cells show all the possibilities on the faces when 2 dice are tossed. Consider the sums obtained by adding the 2 numbers together. So basically we're after what is the sum of the 2 numbers on the top. We will now look at the probabilities of obtaining these sums. The probability of obtaining a 2, the only way you can get a 2 is if you toss a 1 and a 1. So there's only one of those, that's it, there's no more, so that's 1 over 36. The probability of throwing a 3, okay, you have to throw a 3. It's a 2 and a 1 or a 1 and a 2, so that's 2 over 36. The probability of throwing a 4 is 3 over 36, because 3, 1, 2, 2 and 1, 3. And we go through all the possibilities of the additions, so the dice can add up to anything from 2 up to 12. Okay, and you will see that these probabilities are not the same. In fact, can you see which sum has the greatest probability of occurring? Well, the probability that the two numbers will add up to 7 is 6 over 36. That's got a much greater chance, for example, than if you threw a 1 and a 1, because that's only one chance in 36. And it's got a much greater chance than if you threw a 6 and a 6. That's the only way you're going to get a 12. If you throw 6 on top and another 6, that's one chance in 36. So there's another good example to show that the probabilities of all these events, or most of them, are different. They're not equal.